Today I'm going to talk about climate resilient geotechnical infrastructure for a sustainable future. The outline of my presentation is I will be briefly discussing about the research focus, then the contributions which we have made so far in this field, and then concluding remark. We all know that climate change is evident and is a modern day trend. Therefore, we are receiving increased intensity of rainfall. We have issues related to groundwater abstraction as well as drought. And this is impacting various geotechnical infrastructure. Our aim of research is to recognize this interaction between climate and geoinfrastructure, such as subgrade soil, slopes, and foundation. Our approach is more than reactive approach than preventive. We understand we are dealing here with a natural material that has tendency to respond to changing water conditions. And because of that, the property of this material, which is soil, changes under the condition when it is subjected to drying, wetting phenomena. We aim to achieve this understanding through laboratory testing, field monitoring, and numerical modeling. There are several challenges when we look into the field related to geoinfrastructure. As you see that when the train is crossing, and here we have the ballast which is fouled, the ballast is subjected, the subgrade soil, it is subjected to deformation when the train is moving. Similarly, because of heavy rainfall, there was a derailment of Kamini Express, and there were so many problems that has happened in recent years to the performance of various linear infrastructure. As you can see that because of heavy rainfall, there was a collapse of this particular building where the pile foundation is exposed, and coming from Himachal, we received lot of landslides, and the frequency of landslides have increased in recent years. We have seen this year as well as in 2023, and these years were never before when we compare the intensity and frequency of landslides which has increased. So we should realize that the impact of extreme weather event and climate change is accelerating faster than its planning. Therefore, we must incorporate the hydraulic loading while designing geotechnical infrastructure. The way to include it would be through suction, which is the negative pore water pressure present within the soil particle at its contact when the soil is present in an unsaturated state, which is mainly the difference between air pressure and water pressure when water pressure is lower than air pressure. And it is represented in terms of soil water retention characteristic, as you can see over here, which is the relationship between degree of saturation that indicates the amount of water which is present within the voids of the soil to soil suction, and the property of it is highly variable. That means it is depending on how soil is subjected to wetting and drying. Because this particular property of soil, which is suction, affects the strength of the material, its water holding capacity, its volumetric behavior, as well as stiffness, and therefore the infrastructure performance gets affected when the soils are present in an unsaturated state and it is subjected to wetting and drying phenomena. The way to measure it would be through this device which is called tensiometer. This is the device rig that we have developed in our laboratory, aiming to understand the volume change characteristic of the material and measure suction, then represent it onto this space to understand its engineering behavior. In order to first understand that how material behaves under wetting and drying phenomena, combined with the loading that comes because of traffic, let us say for the linear infrastructure, it can be mechanical loading and in terms of monotonic and cyclic. We devised the testing protocol where we kept tensiometer onto the sample, then we subjected the soil to different cycles of wetting and drying, and then we applied cyclic loading to understand the performance of subgrade soil. We subjected the sample to different levels of hydraulic loading. First was free to drain loading, that means the samples were fully saturated, voids were completely filled up with water, and then we applied mechanical loading. We applied another case where we subjected the soil to a constant water content, applied mechanical loading, and then we simulated another condition where we injected the water, applied the mechanical loading, simulated the condition when the rainfall is happening at the same time train is moving onto the pavement. So with the help of this, we were able to understand that the suction characteristic, which is governing characteristic of material strength, is not able to fully capture the material behavior. We need to consider the stages of hydraulic loading. We need to consider that how wetting and drying path is applied. As you can see from here, when the sample is subjected to different drying and wetting path, the samples behave differently. This is the result of cyclic loading. When we apply mechanical loading, which is in terms of monotonic loading, we observe that the sample, when it is subjected to higher hydraulic path, that means the soil developed crack, and that eventually came up in terms of evolution of its deviatoric stress. So it affects the behavior. So we need to account for both of these conditions, and we understood that the cycles of hydraulic loading affect the behavior of material, either it is when it is subjected to monotonic loading or cyclic loading in terms of mechanical loading. Therefore, in order to understand that how we can limit the water infiltration within the material, therefore we developed a technological solution. We chose a waste which comes from water treatment plant, and that is water treatment residue, which is having very high amount of fines. It is high plasticity silt. Being a very high plasticity silt and high amount of fines, it has higher surface area, so it can absorb water onto its surface. So we mix it with the soil, place it onto the top, and then we allowed the system to go for different cycles of wetting and drying. Aim was that when the water is coming into, it can absorb the water into its surface, and eventually it can release it back to the atmosphere when the drying phenomena is. We conducted this test for more than 3 years, so this test is still ongoing, and then we were able to develop this, that we can control the infiltration within the soil. And when we can control the infiltration, we can preserve the compacted state of the material. Either it can be useful for landslides phenomena, or it can be useful for pavements such as railways and roadways. Coming to another topic of our contribution. So through this on combined pile rock foundation, I was introduced to this topic during my master at IIT Bombay. So this particular foundation is usually used for high-rise buildings, where the capacity of both pile and raft are utilized together. And thank you, sir. And because of that, it can serve as a cost-saving foundation alternative. This foundation was successfully used in Messetum Tower in Germany, where $5.9 billion were saved because of utilization of this foundation concept. Earlier, there was no prediction model to obtain the capacity of this foundation system, where we can obtain the capacity of this foundation system by obtaining the capacity of single pile. We have IS code IS 2911 for that, IS 6403 to obtain the capacity of raft. Through our research, we obtained the capacity of, we predicted or we given the equation to obtain the capacity of combined pile raft foundation system by proposing the equation to obtain various interaction factors that governs the load bearing mechanism of this hybrid system. We utilize this concept for several buildings. Out of this, I am highlighting this one particular building of raw material fertilizer plant of Vietnam. And in addition to that, after so many years of working into this, I was fortunate enough to co-author the code of practice, the India's first code of practice on design and construction of combined pile rock foundation, which is IS 19117, recently published by Bureau of Indian Standard. Then we try to understand that when this foundation is subjected to wetting and drying, how this foundation respond to that. And therefore, we subjected the pile foundation to different conditions of wetting and drying. One can be groundwater abstraction, another can be rainfall infiltration. We found out that the groundwater abstraction or the groundwater addition helps in building so much of additional load to the pile foundation, and that needs to be accounted. We considered the case of freestanding pile, where when ground is moving up, it has tendency to move the pile up from the top, and then it has tendency to pull the pile down, and that creates lots of tension to the pile that we obtained through this. And we highlighted that this loading consideration, which is not considered till now into the design, must be considered for lightly loaded structure. We also have developed this physical model at IIT Mandi, trying to understand the water migration, and when the water migration is happening, how wetting and drying phenomena would affect the performance of pipe. We have currently 1 year of monitoring. We are trying to understand the load bearing mechanism of pipe, which eventually can contribute to the practice in terms of design of pile foundation, which is yet to be established. Coming to my concluding remark, through our research, we were able to establish experimental framework for subgrid soil, including water path, hydraulic hysteresis, as well as mechanical loading. We developed a technological solution to limit water infiltration. We provided settlement-based capacity for combined pile rock foundation, as well as we accounted that how changes into soil suction and volume can cause uplift to the pile or tensile forces it can generate to the pile, which was contrary to earlier findings. And also we co-authored India's first code of practice on combined pile rock foundation system. With this, I would like to acknowledge my PhD supervisor, Professor Dipankar Chaudhary, my postdoc supervisor, Professor David Toll from Durham University, my students and funding body, and various collaborating institutions. Thank you very much.